Hello. In this example, I'm going to be walking through the creation of a program from scratch. So here I'm going to be just showing you all the typing that I'm doing to implement a program and how I go about solving it. Okay, so before we get too deep into actually coding, let's look at what we're trying to do. Okay, I want to write a program that makes nice tables that converts from Fahrenheit to Celsius. Now that's not a particularly advanced program, but it will demonstrate a lot of the looping and constructs that we've been talking about so far. Okay, so what I have here is a solution that I won't be looking at that compiles very nicely. And when I run it, this is what it does. What it does is it prints out these nice little tables of degrees Fahrenheit, degrees Celsius, going from -20 to 170. And you know it increments by 10 each time. And for each one, it converts it and tells me the appropriate degrees Celsius. And then I have another table here that does basically the same thing, except here it's starting at 212 and going up to 41 degrees here, showing me all of my degrees C from 100 to up to but not including 0. So it's just generating a couple tables. And then I also have it respond to input, where I can accept in a range of Fahrenheit temperatures and say, hey, if neither of those tables is good enough for you, what would you like? So for instance, let's say I wanted a range of Fahrenheit values. Say I want to go from 0 to 100. So I type in 0, enter, 100, enter, and what it does is it builds me a nice little table for me that goes from 0 to 100 and all the degrees Celsius there. Okay, so that's what the program should do. What we're going to do here is we're going to start writing it. So the first thing I would do is I need to adjust my little compiler line so that it's running the file that I have over here on the right, which is empty. And if I hit go, it complains and it says like there's nothing in here. It specifically is complaining about a lack of a main function. So the way that I tend to write my code is I type a little bit over here and then I run it. Type a bit more over here and then I run it. Because if you wait to run it for a really long time, sometimes it's really hard to find when it starts complaining about errors where exactly the problem is. Okay, so let's start with making my main function. So main function looks just like boilerplate. I'm going to save this and I'm going to try to compile it. And now it compiles just fine. If I run a.out, it does nothing. Okay, so what do we actually want to do here? So let's look at up here and let's see what the first output is. It is printing out these degrees F and degrees C. So how do we make our program do that? Well, in order to do any sort of input or output, we need to do an include IOStream. And then what we need to do is, in order to do this stuff, I'm going to need at least using standard cout. And I definitely want at least using standard end line. And that's all I'm going to include for now. And let's see if we can just make this first line happen. Okay, well that's not too hard, right? We do cout. And then what do we see out? Well, we see out this. So you know what? I'm just going to copy paste it from here. Okay, and note there is 4 spaces between degrees F and degrees C. So we output that line, and then I want to output end L, and then I want to save and run it because I've typed in a bunch of code. Let's make sure it works. So I run it, and it says, oh wait a second, I did not type end L correctly. And this is how I use these errors to help me write my code. I was supposed to say end L, which some of you may have noticed. Save, fix that, try to compile it. Okay, it compiles, and then when I run it, it says degrees F and degrees C. Okay, we're getting started. Now what's the next thing we need to print? Well, the next thing we need to print are these nice little spacers. So what I'm going to do is I'm going to copy that. I'm going to go here and say, okay, I want to cout that. And of course, I forgot my operator here. And then I want to add end L. End L. There we go. And now I can try running that. And then I can try to run it. And it does that nicely. And note, I could get rid of this cout and just keep appending, keep adding more output to the original cout, which is sometimes what a lot of people like to do. And I just lined up my code nicely. Okay, so now what do we have to do? Well, now we actually have to do some math. So let's just try to get out this first output, okay? So the way to cheat is if you just copy that, and then I'm going to say, you know what I really want to do? I just want to output that stuff. Let's see if this works. So if I compile this and run it, hey look, it's perfect, the first degree of output. Now of course you probably want your program to actually be doing some math here instead of just outputting 20 and negative 29. So let's do some actual work here. Okay, so this negative 20, what does that negative 20 represent? It represents degrees in Fahrenheit. So what should the type of that variable be? It should probably be a long, right? It's an integer. And so I'm going to call it Fahren, because Fahrenheit is just a bit too long for me to type each time. So I have a long called Fahren, and what's it equal to? Well, it's equal to negative 20. Okay, and now I have a Celsius here, which is in a floating point. So what type should I use to hold that? Well, I like holding my floating point in doubles, and I'm going to call it Celsius. Okay, and what is the value here? It is negative 28 or negative 28.9. Okay, and so now instead of just printing out those numbers, what I want to do is I'm going to print out, and I'm just going to get rid of that line. What I'm going to do is I'm going to do cout Fahren, and I'll put in a space, and I want to cout Celsius, and I want to put in an end line, and I want to try running it. Okay, so let's run it. It compiles, great, and I run it, and hey, that looks pretty good, except these guys aren't lined up where I want them. So how should I fix that? Well, the thing to line things up is the first thing we want to do is we want to say, hey, we want to have this have a particular width, right? We want to have this be the same width as these number of hyphens here. So how many hyphens are there? There are, looks like 9 of them. So before I do my cout right here, I need to say, hey, I want to set the width to 9. And then I want to output Fahren. And then I need to have these space characters between them. And how many space characters are there? It looks like there is 4. So let's have 4 spaces. And then I want to say, hey, I want to set W again, and I want to set it to 9 again. Okay. And this is starting to get a bit long, so I'm just going to break up the line right here. And then I want to output Celsius, and then I want to output the end of the line. So if I save this and I try to compile it, oh, I'm getting errors. Why? It's because set W doesn't actually exist, right? Because I didn't actually include it. I'm using set W. It's going, I don't know what set W is. And it's like, do you actually mean get W? But it's still not sure. So what do I need to do? Well, in order to get set W, I need to do another include here. So include, and set W is in IO manipulation, IO manip. And if I say using std set W, semicolon. Okay, so let's see if it will still complain about that. Yay, it doesn't complain anymore. And now, oh wait, things aren't nicely lined up. What could be causing that? Well, did I have 4 spaces here? No, I actually only had 3, right? Let's say 1, 2, 3. So let's try fixing that. Compile again, run it. Hey, that looks really pretty now. Now, one thing that note is my 28.9, it was outputting all of my precision. But if I had my number with something like that, let's see what would happen. Now it includes all of that precision. Now, but if we looked way up in here, how much precision do we actually want from all of our Celsius numbers? We only want 1 point of precision. So how do we do that? Well, we actually need to tell cout how much precision we want. So here, let's do that up in the beginning. So I want to say cout, and now how do I tell it what type of numbers I want? Well, here I only want fixed precision. I don't want floating point numbers. So I'm going to say fixed. And then how much precision do I want? Well, I can say set precision 1. And fixed and set precision also need to be included in the namespace up here, just like we would do with set W. And so set precision is part of IO manip, so I'm going to put it right next to that. So set precision. And fixed is part of IO stream, so I'm going to include it over here just so it's easy to keep track of them. So using std fixed. Okay, let's see if that fixes our output. So I'm compiling, it doesn't complain, and hey look, now our numbers are nicely handled. Of course, the numbers I put in here were made it round up, so let's make it so that it would round to the appropriate value. And now that's all pretty. Okay, so if we go back to our input, we just handled the first line. But we need to do a whole bunch of lines, okay? And if you need to repeat something many times, you should be writing a loop. So how do we write a loop that handles this? Well, we need to make a loop that handles all of these printing things out. Okay, so what I'm going to do is I'm going to go right here, and I'm going to say, hey, you know what? We don't want to just print out these two values. We want to print out a bunch of them. And now, what sort of loop do we want? Well, we can use a while loop or a for loop, but here's a good example of using a for loop. So if I say for, and in my curly brackets, I'm going to include this cout line, and then I'm going to tab all this over because I like tabbing my stuff when it's blocked in here. And now my for loop should go and print out all these values. So where do I start? Well, starting at -20 is a good spot. So I'm going to say here is my Fahrenheit value. Fahrenheit starts at -20. Great. And how does my Fahrenheit value change each time? It goes up by 10. So how do I make Fahrenheit go up by 10? Well, easiest way to make Fahrenheit go up by 10 is say Fahrenheit. Gosh, I can't type right now. Fahrenheit plus equals 10, right? Because remember, 10. So this would make Fahrenheit go up by 10. And now for loops also need a condition to see when do we stop. When should we stop? Well, we want to stop when we get to 170. So how would we go do that? Well, we would say Fahrenheit must be less than or equal to 170. All right, sounds good, everybody? Okay, so then we would print out Fahrenheit, we'd print out Celsius. Well, this was a lot of typing. Let's save this and see what happens. So I'm going to compile. It compiles. I run it. Hey, look, beautiful. We go from -20 to 170. Of course, we just keep printing out the same Celsius value, which is wrong for everything except for the first thing. So hopefully you guys remember how to calculate, how to convert between Fahrenheit and Celsius. If not, you can always look it up. But so the way that you do this, you say, okay, Celsius is equal to, and now what's the math? Well, the math is you take your Fahrenheit value, so Fahrenheit, you subtract 32 from it, and then you multiply it by 5/9. So 5 divided by 9. All right. Now there's some small mistakes here. So the first thing is we need to do this subtraction before the multiplication. So in order to make that happen, we need to put parentheses. Okay. The next thing we need to concern ourselves with is what is 5 divided by 9? 5 divided by 9 is 0, right? Because these are both integers. So really we want to get a floating point number between these. So we want 5.0 divided by 9.0. Now this would give us the floating point value of this division here, which is actually what we want in this case. And then we'd multiply them together. All right, so let's save this and see if this works. Oh, here, actually, it's not going to compile because it's going to complain about me forgetting a semicolon. Let's put in that semicolon. Okay, we run it. It seems to compile fine. We run it, and hey, these values look pretty decent. So we go from -28.9 to 76. So let's see if that's in the correct output. 76. Great. Now, okay, so now so that is actually our first output, right? We have a nice little for loop that outputs this. And now let's look at what our correct output should be. We also have another little table that we output here that goes, once again, degrees F, degrees C, but this time it goes from Celsius degrees of 100 to 5. Okay, so can we write that? Well, that's not too hard to do since we already got this working here. What we can do is say, okay, well, oh, one other thing. You note there's a little, okay, so let's figure out how we're going to do this. Well, this is going to look a lot like what we did above here. And I'm going to print this out here. So now instead of looking at Fahrenheit, we're looping over degrees Celsius here. So what I'm going to say is Celsius is equal to, now where does Celsius start? Celsius starts at 100.0. Remember, this is a double, so we should always be floating point. And we want to go Celsius, let's say we want to do Celsius greater than 0. As long as Celsius is greater than 0, we're going to do this. But we said greater than, not greater than equal, so it won't actually print out 0. And now how is this changing? It's changing by every 5. So we want Celsius. And now we're starting at a big number and going down, so we want to subtract equals 5.0. Okay? And now we want to actually calculate this time what our Fahrenheit value is. So this is kind of backwards. We want to say Fahrenheit is equal to, now how do we do this math? Well, this math is not too hard to do. We do Celsius times 1.8 plus 32. And I'll just make that a floating point number. Okay. And then what do we need to output? We output Fahrenheit and Celsius again. Okay. So let's save this and see if it compiles. It compiles. Let's run it. Oh, we got it pretty close. See here, you can see the second output coming out here. But what we didn't do is we didn't copy the outputting the header of our table. So let's copy that code as well. Okay, so we've copied that code. Let's compile it. Let's try running it. Oh, that looks much better. We probably would like a little new line separating our tables. So what I'm going to do here is I'm just going to see out an extra end line here so that it spaces out our tables more nicely. And we compile it, we run it. Hey, that looks really great here. Okay, so now what do we have to do for our correct output? Well, in our correct output, and now it's getting kind of farther back in history, we ask the user to give us a range of Fahrenheit values, a smaller number and then a bigger number, and then we output the table between them. Okay. Well, that's not particularly hard to do. Note there's a little new line before we ask our input, so I'm going to just do that right now. So we cout and L, and now we want to output this line. I'm just going to copy it from here. Cout. We want to output that value with the space there. And now we want to read in two values. Okay. We want to read in two. Now, which of the types of these values? Well, we've been keeping Fahrenheits as integers, so let's just assume the user will always give us two integers here. All right, so how do we read in input? Well, we need to use cin. Oh, okay, well, if we're going to do cin, we need to include that up here. So include cin, and without the space there. Okay, so now we have cin. And now we want to read in, what should the first value be? The first value should be the smaller one, so I'm going to call it lower. And then we also want to read in another number, which I'm going to call upper. Now, of course, I haven't declared these two variables, so before that point, I need to say, hey, should be a long lower, and there should also be an upper. And then for right now, just for testing purposes, let's see out lower. And whenever I do input and output, I always kind of test my numbers to make sure that we aren't running into any problems. Upper and L, and be done with it. Okay, so this program right now, it should ask for a range of Fahrenheit temperatures. It should read those two values into lower and upper, and it should see out them and then stop, and then we'll worry about making the table in a little bit. Okay, so let's try compiling this, and it doesn't compile because it's complaining about cin here. Ah, I forgot to say using here. Alright, and this line is getting a bit too long, so let's just break it into two. Alright, let's see if that helped. Okay, so now it compiles, and now we try running it. It still prints out all our previous output. And so let's give it, 0, 100. And it prints out 0 and 100. Great. Okay, so now we're not supposed to actually just print out 0 and 100. We're supposed to print out another table. Okay, so how do we go and do that? Well, we have this nice code right here that prints out a table. So instead of outputting it, we're going to put this bit in here. And now this stuff is too indented. So we're going to print out degrees F, degrees C, and then here, what should our for loop go from? Well, here we're back to the Fahrenheit. So you know what? I should have actually just copied. I'm looping over Fahrenheit value, so I'm going to copy the Fahrenheit code here. And now where do we start at? Well, now here we don't start at -20, we start at lower. And when do we go up to? We go up to upper. How much should we go up? Let's just keep going up by 10. That seems like a nice reasonable value. But the rest of this code works just fine. So if I save this and I compile it, hey, it compiles. If I do a.out, it prints out all the stuff beforehand. And if I do, I don't know, I want to start at -200 and I want to go to 50. It goes from -200 to 50. So this is my process for how I actually code C++ programs. Now note, I didn't just type all of this file all at once and then just run it over here and make sure it works. I type a little bit and I correct myself. I type a little bit more, I correct myself, and work my way all the way to the finished product. That's how I recommend writing your code. You should really never write more than a few lines over here before you compile it and before you execute it to make sure it's doing what you want. Okay, so that's my method, and that will help you a whole lot in all of your future classes. Just remember, if I typed all of this in and I was starting to get some error on this line, it would be hard to tell if the error was actually on this line or if it was related to all the other code that I typed since I last compiled. All right, good luck.